Okay, question 5 is a binomial theorem question. Now in C4, the binomial theorem takes a change in that we have negative and fractional indices possible. Now what this means is that you can't have a limited expansion. There is no obvious way to expand brackets to the -2 and get a polynomial expansion on this. What we do is we can realize that we can use the binomial theorem to expand this up to a limit power, because what we can do is if x is smaller than a certain value, i.e. the thing you're raising to a highest power is less than 1, then what will happen is the expansion will get closer and closer to 0 as you go on, and that is what we use in the binomial theorem to expand negative and fractional indices. First of all, we need to get them in the form of 1 plus x to the n. And here we can see we've got 2 minus 3x to the -2, so we've got to change that 2 into a 1. And we do that by dividing by 2. So we need to take out a common factor of 2 out of this, and when we take it out we need to raise it to the power of -2. So therefore 2 minus 3x to -2. Take out a factor of 2, raises the power of -2 when we take it out, because that's what you're going to have to do. Leaves you just 1 here. If we write the plus, then we're taking out a factor of 2 here, so we get -3 over 2x, so -2. Now in the expansion, this now becomes our x value. We know that this is just equal to 1 plus nx plus n times n minus 1 over 2 factorial x squared plus n times n minus 1 times n minus 2 times x cubed over 3 factorial plus, and so on. The pattern carries on, and this will work for fractional negative indices provided that x is less than 1 and bigger than -1, or the modulus of x is less than 1. So we're going to put this value into here for x. Everywhere there's an x, this is what we're going to put in here, and then we can get this expansion, and the power here, n, is -2, so everywhere there's an n, we're going to put -2. 2 to the -2 is a quarter. So we're going to do a quarter times 1 plus -2 times by -3 over 2x. That's what x becomes. -2 -2 minus 1 is -3, so -2 times -3 will give me 6, divided by 2, 2 factorial is 2, which will give me 3. Lots of x squared. And we can do the same with the x cubed term. We've got -2 times -3 times -4. So we're going to divide by 3 factorial, which is the same as 2 times 3, so these two will cancel. So you've just got to check your signs, minus times minus times minus, odd number of minuses, so that will end up as -4 once you've cancelled it all down. And the x is just -3 over 2 cubed. Now I've made a silly mistake here. Let's just correct that. I didn't substitute this in for my x. -3 over x squared. And the reason why I spotted that, I was about to say a common mistake here is actually not to put the -3 over 2 to the power, and I was just checking through that I'd done that. Quite often people just write the power after the x and don't raise the -3 to the power. Well, actually I hadn't even substituted the right x in here, and this carries on, but we're only asked to go up to x cubed. So expand this all out and simplify, get a quarter times that gives you a quarter, so we're going to get +3 over 4 x, and we're going to get 27 over 16 here. Once we've cancelled this all down, 3 squared is 9 times 3, so we get 27 over 16 x, 4 times 2 squared, 16 x squared, and then we're going to get, we've got 3 cubes, 27. We've got the 4 times the quarter will cancel, and that will be over 2 cubed, which is 8. the signs, we had that 3 powers there, so that's an odd power, so that's negative, times negative gives you a positive. And that is our answer to part A. Right, in the second part of the question, we're told that f(x) equals a plus bx, all divided by 2 minus 3x squared. So we've effectively got the same part of our previous expansion, just times by a plus b. So what we're going to do is, in the binomial expansion of this, in the ascending powers of x, the coefficient of x is 0 and the coefficient of x squared is out, and we're going to find a and b. So we need our previous bit of working, and what we need to do is we need to times that by a plus bx. Just in case you haven't spotted it, we've got a plus bx over 2 minus 3x squared, which is the same as a plus bx times by 2 minus 3x to minus 2. And this is what we expanded in the previous bit to get this. So we're going to times this all out. And if we times this all out, we'll be able to find out what the x coefficient is and what the x squared coefficient is. So the x coefficient will come from, let's just write down, for the x coefficient, we're going to have a bx times a quarter, which that will give us a quarter b. And we're also going to have an a times 3 quarters. And we know that the x coefficient is equal to 0. So therefore, we can simplify that to, if you multiply by 4, you will get b plus 3a, which means that b will equal minus 3a. Now for the x squared coefficients, let's look at those. We'll get a bx times 3 quarters x, so we get a 3 quarters b, lots of x squared. And the a will get a times 27 over 16, lots of x squared, from a times this term. And there's no other ways we can get x squared. And we're told that that equals 9 over 16. So we can simplify this as well by times throughout by 16. So we'll get 12b plus 27a equals 9. And we've got a common factor of 3, so let's just cancel down by that to make things a little bit easier. 3 into 27 goes 9 equals 3. And we know that b is equal to minus 3a. And we can solve this to find a and b, so let's just do that. So b is minus 3a, so therefore this is going to be minus 12a plus 9a equals 3. So minus 3a equals 3, so a equals minus 1. And therefore b will equal 3. Now in part C, we're asked to find the x cubed coefficient and give us as a simplified fraction. So for x cubed, let's just write that down here so we can see everything. So for x cubed, we're going to go bx times by x squared to get an x cubed term. So we're going to have 27 over 16 lots of b. And then we're going to have a times 27 over 8. So that will equal 27 over 16 times 3 minus 27 over 8. Now effectively that's going to be 27 lots, if we turn this into 16s, we're going to times top and bottom by 2, so we've got 2 lots of 27 over 16, and here we've got 3 lots of 27 over 16. So the answer will just be 27 over 16. It's a simple way to get to the answer the quickest, and we can't cancel this down anymore, so that's our final answer.